Hello guys, and welcome to another video. On this video we'll be looking at the concept of molar volume of gases. Okay, and the main thing that we firstly have to know about this topic is what? Avogadro's law. But you will remember that there was something that we had already talked about that has to do with Avogadro, and that was the Avogadro's number. So this time we are looking at Avogadro's law. Okay, and this is what Avogadro's law states. It states that one mole of any gas occupies the same volume at the same temperature and pressure. Very simple, that if we have 1 mole of any gas, it will occupy the same volume at the same time, or rather at the same, not time guys, at the same temperature and pressure. Okay, that's what Avogadro's law states. And there's this thing we call STP, which has to do with this law, because the law tells us that if we have any 1 mole of gas, it will occupy the same volume at the same temperature and pressure, and that means the situation would be under STP conditions. Okay, what does this STP mean? It means that you have your standard temperature and pressure. So this means that this 1 mole of any gas will have the same volume under STP conditions, standard temperature and pressure. What is that temperature? That temperature has to be equal to 0 degrees Celsius, or it can be 273 kelvins. Okay, and then the pressure would have to be 1 atmosphere, or you can say 101.3 kilopascals. So that volume will be the same under these conditions. Okay, under the standard temperature and pressure, and those are the volumes. And you do not have to worry about these volumes and these values guys, because they are given to you when you are doing your calculations or writing your exam or test. They are at the back of your information sheet, so you don't have to memorize them. You just have to know that these are applicable under the situation of you making an application of Avogadro's law. Okay, then under those situations, we said that 1 mole of gas will occupy the same volume, right? 1 mole of any gas will occupy the same volume at the same temperature and pressure. That's the definition. So what is that volume? That volume is called the molar gas volume, right? And it's denoted by this Vm. And here you can see that at standard temperature and pressure, 1 mole of any gas will occupy a volume of what? 22.4 dm cubed, or decimeter cubed, or cubic decimeter. It's up to you how you call this, but I'll say decimeter cubed. So that volume that we're talking of 1 mole of any gas will occupy this amount. That volume is this amount, 22.4 dm cubed, and this means that our molar volume will be equal to 22.4 dm cubed per mole. All right, and this volume here is also a constant. So when you are looking for the molar volume of Vm, you must know that it's always 22.4 dm cubed, but sometimes things can change. However, in the case of grade 10 and 11, this is the same amount, but sometimes they can give you guys a different volume. They can say at STP 1 gas or whatever occupies this volume. You just have to look out for those things, but in this case your volume is the same. All right, so that's what you need to know in terms of this amount of volume, that it's 22.4 dm cubed per mole, and we call it the molar volume. All right, I hope that makes sense. Now we are gonna go further to look at the gas volume equation, okay, whereby we are gonna use that molar gas volume, which is 22.4, to do what? To find the volume or the number of moles. Remember that this Vm is the molar volume and it's a constant, so this one will always be given to us. Let me just quickly highlight it. The molar gas volume guys will always be given to you. See this one, it's a constant, so it's given to you. What is it equal to? It's equal to 22.4. It's given to you. If you forget it by any chance, worry not, it's given to you as well on your information sheet. Right, now let's look at what each thing on this formula stands for. we have our N, and the N stands for the number of moles, but we already know this from the mole equation calculations. We also have our V. This is the volume of gas, and it's measured in dm cubed or decimeter cubed. Number of moles measured in moles, or has an SI unit of moles. Then we have Vm. This is the molar volume, which has a value of 22.4 dm cubed per mole at STP. Okay, hope we understand everything that's on our formula. Now let's use that formula, the molar gas volume formula, to calculate. Okay, remember, we will either calculate the number of moles or the volume, because this Vm is already given. I'm gonna go back to the formula. This Vm that I've highlighted in yellow is a constant, so we will normally use it, the formula, to calculate N and V. I hope that makes sense. Let's look at our examples now. Okay, here's our example. It says we are going to find the moles from volume. How many moles of oxygen gas are contained in 11.2 dm cubed at STP? So this is what we do before we do our substitution. We write the information given here. We have V, which is equal to 11.2 dm cubed. Remember that volume is measured in dm cubed. And then we have Vm. Vm is 22.4 dm cubed per mole. Remember, this one is a constant. And the reason why we know we have to use this thing is because of what? This situation here at STP. Once you see those words at STP, then you must know that the formula that you are going to make use of is N is equal to V over Vm. Okay, and what are we looking for in terms of this question? We are looking for N. So the information that we have are the two volumes. And now that we know what information we have and what we are looking for, we'll write down our formula to say N. We'll write our formula to say N is equal to V over Vm. Okay, and then we can substitute from here. What is our V? It's 11.2 is equal to, what is our Vm? It's 22.4, and then press the calculator to find our answer. 11.2 divided by 22.4, and the answer I'm getting is 0.5 moles. So this is our volume, our number of moles using this formula. Okay, that's pretty much how you do it. Let's go to the next example. The next example here says we are finding now what? The volume. So it says, what volume will 3.5 moles of nitrogen gas occupy at STP? So in this case, guys, you can see that we are given the number of moles, which is 3.5 moles, and at STP means that we are working under the conditions of standard temperature and pressure, where our molar volume in this case will be equal to 22.4 dm cubed per mole. Dm cubed per mole. You don't have to write the units here, by the way. I'm just doing it to remind you that the molar volume SI unit is dm cubed per mole. But when we are working maybe in your exam situation, you just want to dive straight into the answer. Okay, so this is the situation we have. We have our number of moles, and we also have our molar volume. Why do we have this one? Remember, this one is a constant when we are working under standard temperature and pressure. Like I've said already, when you see STP, you must already think of this, and you must also think of this formula. Let me write down that formula. N, okay, excuse me about that. You must think of this formula. N is equal to V over Vm. Okay, and then you can substitute into this formula. What are we looking for this time around? We are obviously looking for V. Our number of moles, let me just fix my equation here. Our number of moles in this case is 3.5 5 is equal to V is what we are looking for. That's what the instruction said. It said what volume? So we are looking for V. Then we divide. Our molar volume is what in this case? Remember, Vm is a constant, which is 22,4. Then we can just do our calculations here. We'll cross multiply. V multiplied by 1 is going to give us V. Then we'll say 3,5 multiplied by 22,4. Let's see what answer we get. 3,5 multiplied by 22,4. And the answer we get is 78,4. So that's our volume. 78,4 dm cubed. That's the unit for the volume. And that's how you do the calculation, guys. Let's go to the next example. Okay, here's the last example in terms of this video, guys. And this one is a bit more complex. Okay, there's more into it in terms of steps. So here they are saying we're going to find the volume from mass, okay, or mass, I don't know how you want to pronounce that. And it's a two-step calculation, as you can see. So things here are a bit more complex. And the question says we have to calculate the volume occupied by 8,8 grams of carbon dioxide gas at STP. And the molar volume of carbon dioxide has already been found for us. It's 44 grams per mole. I want you to know something, guys, that every time you are given mass, and I'm not talking of molar mass in this case, I'm talking of mass as in the small letter mass, okay, which is measured in grams. You must know that you are going to have to find the number of moles, okay. So that's what we are going to do. We are looking for what here? We are looking for volume. So let's just list down our information. We are looking for volume, and we do not have the number of moles. Remember, if we are looking for volume, we use the formula N is equal to V over Vm. But as you can see, we do not have the number of moles. So that's what we are going to have to find. But we are given the mass, and we are also given the molar mass. The molar mass in this case of carbon dioxide is 44 grams per mole. Okay, that's the molar mass. So we are going to use that information to find our volume. So the first step, guys, is for us to actually find the number of moles. How do we do that? We go to the mole equation, which is N is equal to small m over big M. Then we are going to substitute here. What is our small m? Our small m is this one here, 8,8 divided by, what is our big M, the molar mass? It's 44 grams per mole. So here I'm just going to say 44. And then I'm going to do my calculations to say 8,8 divided by 44. And the answer I'm getting is 0,2. So my number of moles is 0,2 moles, right? After I've found my number of moles, I can now finally find my V by writing down this formula to say N is equal to big V over Vm. Do I know Vm? Yes, I do. Remember, Vm is a constant. It's a molar volume constant, which is 22,4. So this one I already have. I just found my N, which is 0,2 is equal to V is what I'm looking for. And what is my Vm? My Vm is 22,4. And then I can just cross multiply here now to say V times 1 is equal to V. And then what is 0,2 times 22,4? 0,2 multiplied by 22,4 is equal to 4,48. What's the unit for volume? It's dm cubed. And that's how you pretty much do your calculation. And yeah, that's it for this video, guys. I hope it was a helpful video. We're looking at calculating the volume and number of moles in terms of using the gas volume equation. So we're just playing around with this formula today. I hope you got to benefit from this video. Please do also share the video with your friends. Also do like the video, guys, and subscribe to the channel if you have not done so already. I'll see you on the next one. Bye bye.